I've been assembling a casting setup for a while now. With it almost complete, it's time to start making some patterns so I can cast something. One of the things I've been wanting to cast are parts for the zither style banjo, so in this video I'm going to make some patterns for them. I'm making this pattern out of two sheets of 9 and 12mm MDF. The inner pattern is 30mm tall. That requires 2 layers of 9mm and 1 of 12mm. A centre hole is being drilled to locate the layers. Patterns require a draft angle to get them out of the sand. This is probably what makes them so awkward to construct. The board's going to be used as a table for the belt sander. It's angled to about 4 degrees. The spindle's then stuck into another scrap board, and the nail's used as a pivot. This allows it to be advanced towards the belt sander for sanding the discs round with a 4-degree taper. It's not the safest setup. For getting the inside out, I drilled all the way around, but it would have been better to use a jigsaw. The inside needs to be tapered too, so I'm setting the angle of the drill press table. And here's a setup for truing the inside. It's a very crude version of Ronald Walter's machine. The weights provide tension on the levered arm to help hold the ring against the rollers. The rollers being the V-belt pulleys I'd made for the belt grinder. It's very dusty and slow going. The 2 nuts and the clamp are loosened to advance the cut. The sand drums are also from that belt grinder. Cut up sanding belts were held on with carpet tape. It would have taken forever to sand the thing down, so I'd trim closer to the scratch line with the jigsaw. I did eventually hook up some dust collection. The pattern has 18 tabs around its circumference. I marked out the rounded part with a round rod. The draft angle made these parts awkward to produce. The sides are sanded to an angle on the belt sander. The back needed a slight concavity as well as an angle to match the tapered ring. The pen line tells me how far to sand to. The belt sander was a bit too aggressive and had a tendency to fling the parts, so I used the drum sander to sand the radius. The vise was quickly made from scrap hardwood. It worked pretty well. And that's them all done. Aside from a little cleaning up. For positioning them around the circumference, I made this template. The positions didn't need to be hugely accurate since I could make the other parts to fit. A bunch of rubber bands tied together hold them flat against the ring as the glue dries, and weights hold them against the table. I didn't record the other pattern because it was pretty much made in the same way. Tighten and fillet the pattern. Filleting is round in the inside corners of the pattern, I suppose to strengthen them and to prevent them from cracking as the metal cools. Car body fill is often used for this. The first attempt really didn't go very well. The body filler wanted to stick to the pen I was using more than it wanted to stick to the MDF. It required a lot of cleaning up. I used some plaster wall filler for the second pattern. It shrunk as it dried and the cracks needed a second pass. I found that using a thin knife-like tool prevented the stuff from sticking to the tool more than the MDF. The body filler probably would have worked fine if I knew this. The patterns are then primed and painted. I'm using high build car primer for the first coats. The dip straw must have fell out, so I need to hold the can upside down. And finally it's painted with black car spray. I better say right now this casting attempt was a disaster, so consider it a bonus feature, or a cautionary tale. For the crucible I was using a stainless steel toilet brush holder made out of what seemed to be a reasonably thick material. The sand is a Mansfield red green sand. It was given to me by a canny fella called John, who has a YouTube channel with great videos on casting as well as machining. He also gave me the burner I'm using. First the pattern's covered with parting dust, or talcum powder in a sock, to help prevent the sand from sticking. The first layer of sand's riddled through a screen to get the lumps out. Then it's rammed down and compacted. The idea is to ram it hard enough that it doesn't fall apart, but not so tight as to reduce the porosity and then prevent steam from escaping. Then the surface is strickled off with the strickling iron to flatten it. And the moment of truth.
Oh, look at this.
The second attempt. This time I figured the sand was a bit too dry, so I wetted it a bit. Success was short-lived though.
Oh, yeah.
At this point I'd given up on casting the pot, so I decided to just make a couple of troughs in the sand to pour the molten metal into. I'd made some ingot moulds, but I wasn't convinced they'd be leak-proof. The burner's sputtering at this point because of the drop in gas pressure as the propane cools down. As soon as I heard the popping, I shut the gas off and moved the camera out of the way. Turns out the crucible burnt through. Probably would have held for a melt or two if I'd had my act together. I thought I would have had plenty of time to make the mould while I was waiting for the metal to melt. I just couldn't resist getting a closer look. That's the water absorbed in the concrete the metal is sitting on. Water absorbed in the concrete boils and pressure blasts the concrete off. You get the same effect indoors as well from the hydrated water. I then managed to break the container I was storing the sand in. I only dropped it from about half a foot, but that was enough to crack it. I also broke the garage door, rolling the furnace into it. And then the lining and the lid fell out. The weld beads I'd used to hold it on didn't protrude out enough, I suppose. I don't think I'll try casting again till I got a proper moulding bench and crucible. I jumped the gun with this because I don't really need any parts cast for a while. Thanks for watching.